Let me introduce the resource person, Saravanan Sellamuthu, software consultant, UK. He completed MCA. He is having 15 plus years of experience in software industry in UK. He worked as various positions in software industry. Once again, I welcome Saravanan Sellamuthu sir in this August occasion. Saravanan sir, can you please take over this session?
Yeah, sure. Thank you. Hi everyone. Let me share my screen. Yep. Can you see my screen? Yeah. So today's session is basically. Let me introduce myself. As you said, I've been working. And then Python and other Bash scripting. So I worked on different wide range of technologies. But to my experience, Google Go is far superior language compared to all our traditional stacks like .NET, Java. So if you have been studying in India, most of you guys must be familiar with either Java or .NET. So 15 years ago, when I did my MCA, the hot technology was Java. Nobody knows anything else other than Java. Even today in India, .NET and Java are the predominant languages because you have a wide job market for those two technologies compared with other ones like Python or Golang or even infrastructure side of things. So today's talk, I would like to address how Go is a better programming language compared with all your traditional stacks. So I want to show you what comes out with Go as out of the box and compare it with other traditional languages. So if you look at on your right, probably or left for me, so you have the default ones come out of the box, like you have a library support and you have massive concurrency inbuilt to the language itself. So there is no multi-threaded code to be written in Go, which you have to do on other languages like .NET or Python or any other language. And Go is simple in syntax and has got only 32 keywords in its entire language stack. And it's pretty easy to learn. And it is backed by very big companies now. Google supports, it's the language developed by Google. And the founders of the Google Go are the pioneers who invented CN from AT&T Bell Laboratories. When it comes to programming languages, still C is predominantly used in all the low latency applications, particularly trading platforms where latency is very key. So the founders of C, they thought the languages have evolved in the past 10, 20, 30 years, but hardware has also evolved along with it. But the language doesn't support multi-core and accessing the full resource of your CPU. So that's where the modern languages lack. So they came up with designing a brand new language right from scratch in 2005. So that's how Go evolved. And if you look on the other side, Go doesn't have these following features called session management, security, or routing. The reason is they want to keep it simple and let these side of things, let the developers to come up with their own design solution for the bigger picture. So there is I'm using for this demo one of the toolkits called Gorilla Web Toolkit. So you can Google and find after the talk this is all about. So basically, in a nutshell, this is a very small, very lightweight toolkit which lets you address all these missing pieces on your right. So if you look at the what do you get from Gorilla Mux? You get a router, a whole bunch of things. I'll let you. I'm not going to go into detail on explaining what everything does. And then, so if you look at all the leading technologies, like if you used Google, Gmail, or Facebook, or any latest social media ones, you might have seen they don't ask your password that frequently. So they don't, they maintain all on the cookie itself. There's no session being handled. So that's the new trend evolving in the web technologies. They want to keep everything lightweight and less load on the server side so that they can scale it horizontally along thousands and thousands of requests. So that's the key thing they use. So if you go and open your inspect tool on Google Chrome, you will see most of the cookies all are cookie based for Gmail. So there is no session being used on these. So that Gmail app doesn't have to hold any of your information on the server side. So that makes the application by native itself to scale for millions of users. So that's the key secret recipe behind their highly scalable applications from Google or Facebook. If you look at the way they do it, they don't. So cookies, they are very lightweight, and the maximum size for your cookie is only 4 KB. And so if you put plain text on the cookie, it becomes human readable, and anyone can get access and hack your information. So to prevent that, they use an HMAC algorithm and encode everything. So all the cookie you will get to see on your Gmail or Facebook, they all are encrypted using an HMAC algorithm. So the way the HMAC algorithm works is your source code will have a key value pair, and you use a private key and pass through the HMAC algorithm. And the HMAC algorithm will give you again a value and a hash of that value. And when you want to decode it, you use the reverse of it. So you pass the hash value of it and use the private key and get the value out of the hashed encoded cookie. So why these famous technologies, they don't use sessions? That's the key thing to observe here. So if everything has to be handled via sessions, then the problem is the user information has to be maintained in memory. So imagine an app like Gmail or Facebook, if they have to do this on the server side, it's going to be really huge cost for them to have a huge servers with a big RAM on them. So it's going to cost a lot. So to avoid that, what they do is they rely on leveraging the cheap CPU cost. So nowadays you have multi-core CPUs, and CPU costs have reduced because of cloud computing. So what these guys do is they don't have a high-end heavy RAM for their application. So instead they rely on the CPU to use and generate the HMAC cookies. And once the cookie is generated, you pass the cookie on the request. So every request will carry the whatever cookie you have it on your request header. So that way they don't have to hit their database servers every time to authenticate it is you who is actually accessing the request. So that's where instead of doing sessions, most of the applications these days they do it via cookies. So that's the nutshell I want to talk about. Now I will go for a little demo of how the pieces work. So I got a small demo app, and so this is the smallest line of code you could think of in Go. It's the most simple hello world application. So the beauty with another thing I missed to say was the beauty with Golang is it comes with its own inbuilt HTTP server. So you don't need a separate web server to deploy your applications or anything. Like if you are coming from a traditional Java background, you might be knowing the language has its own build tool. Java is a language. It's not a build tool. It doesn't have any build facility to do. You have to do all your handcrafted. You need Maven, and then you need a whole bunch of dependencies, third-party libraries, whole bunch of stuff, and then you have to write your POM file and all those things. And then you need a web container to deploy your web application. And then the web container makes a communication with the inside JVM, and then it loads the application for you. That's the way a traditional Java stack works. And so even though so Java has been a very mature language. It has been in the market for around 25 years. The success of the Sun Microsystems Java was they branded it by calling it platform independent. So that's the key word which made Java very popular in the early days of 2000s, and a big boom of all the tech companies. They all moved to Java as a crowd, and that's where the job market created a huge demand for Java developers. But that trend is no more happening. There are lots of other non-conventional tech stacks evolving, like Ruby, Golang, Django, Python's famous Django framework, and then Node.js based Express, and then React. So there's a whole bunch of non-traditional stacks evolving. So among all the non-traditional stacks, I picked Go as the best one because it's got server-side development as most strength of it, and this Golang application comes with its own default HTTP server, which is not present in most of the languages you can imagine. So you don't have to actually deploy this application that I'm going to demo into a web server. You don't need a web server, in fact. And you don't need a JVM also. There is no JVM, concept of JVM here. The language compiles it to a binary code, which is native to the operating system itself. So there is no warming up needed. So if I have to deploy my Java application, the Java compiles into bytecode, and then you have to, the war file or your jar file needs to be deployed into a container like Tomcat or Jetty or JBoss. And then JBoss has to make its low-level calls to the JVM, and then the application loads. And if I have to deploy my war file, I need to first install JVM on my target machine. Without installing JVM, you can't deploy you can't even start your Tomcat on the server. So when Java claimed like it's platform independent, it is not actually platform independent. The reason is it is JVM independent, right? A truly platform independent language mustn't have a dependency on another something to be installed on the target server. Do you get the point? So the target server always needs JVM. Without JVM, it's not you can't deploy your application. It will fail basically. So that is not true platform independency if you think on a high level. This is where Golang differentiates much there. So if I have to run this application, I can build the application and it will create a binary file. And if I deploy the binary file doesn't need any software to be installed on the target server. It can straight away make concurrent calls, everything at the low level, OS level communications, which makes the language so highly scalable and performant compared to other Java-based stacks. The reason is there is no JVM involved, and there is no warm-up of the application needed. There is no web server needed. All you need is it's native binary file, which makes it more robust. So if you look at this code, the code is a bit self-explanatory. So I use only one of these Gorilla toolkit, which is the library which I talked on just ago. So which is this Gorilla toolkit. So if I have to import that, I just make a call for this import. And once I import, it becomes native to the application now. So all I do is I create a router, and then I have a handle function because I have my request for the / localhost is going to handle by my home handler, which is this one. So my hello world application is just printing out hello. Let's make it hello world. And then if I want to run this application, all I need to do is just go, and then I do go run hello.go. once I hit the server, it will give I log a small message saying, okay, my server is started on port 8001 and you can access it now. I'm ready. So I go on the browser and then I go type localhost 8001 and you will get to see hello world. Okay. So we got the hello world covered. So let's make it a little bit different than the hello world. So what if I want to, hello, does anyone have any question? Okay, I'll continue. Yes, so if I have to make this application a little bit more better than a hello world application, let's get into a better version now. So this is so I have a model. You can call this as a model, like a person model, or in Golang we call it as struct, but in other languages I know you call it as a model. I'm not using any database here. This is just a hard-coded model for now for this explanation. So I have a model which is just basically taking first name, last name, your email, age, gender, and then the current year. And all I do is I have a router which just create two handlers. So one will take the root requests and then another request to take the /template one. And so here now I want to use some templates. So the reason I want to use some templates is I want to have this hello world is just pretty boring. You know, there's no design, no colors. There's no front end. It's just a static one, but it's a web server basically. So now I have created some templates, and I will show you my templates. So you can imagine templates as your front end or your view level. And so if you look at my base, this is my base template. So this is my base template, and my base template has it's like a normal HTML. You know, I have a header, and I have made the header into another template, which is making a call here, and then I have a navigation element, and then I have a flash message, which you don't need for this small demo. Right, and then you have a body content for your HTML, and then you have a footer, and then you have a bunch of JavaScript loads because I am using jQuery and Bootstrap here for this small demo. So that's said, let's have a look at the other ones. So I'm making a reference to a header one. So let's open the header.temple file. So the header is nothing but is just a bunch of CSS and a title. This is the interesting bit. So I have a title template, and then I have the footer. Footer. If you look at the footer, I'm making a reference to the current year. So if you look at my hello world.go, so you see I'm getting the current year here. So let's come back to the current year in a minute. Okay. And then I have my own test page.temple. This is the page that I'm going to render all my first name, last name, and email, age, and gender data. So you can see my test.page template. Here I'm saying, okay, my page uses the base template, and the title for my page is person list. And this is my content definition, where I just able to display the table of the first name and last name. And if I go back to my temple application, this hello world application, so I have a template handler, as I showed you here, which is a handle function. And so the handle function is basically I wrap all my templates into a single file element. So because my test.temple page, test page won't work without these templates. So I'm wrapping them all into an array of strings and then passing those files to my template. So and then I'm just doing a bit of error handling. So make sure there's nothing wrong with passing the files during the process. And then I get the current year, because my footer, if you remember, makes a reference to the current year. And then I create a dummy person array, which has some dummy data to it, which is an array of model or array of structs, you can call. So I have 2 of them on my list. And then I say, ask my application to execute the template. TS is my template, which is the reference to all the template files. And then I say execute the template, and then I write it to the right object. So in Go, there are all the template function will have this argument, which is a response and a request. So all the HTTP requests have 2 pieces to it: a response and a request. So they take an argument of them both, and the request is always a pointer, because all your requests need to have the reference to the root of it. So and then I pass the person my object to the template. So now, and if you go to my test page temple, I iterate through the all the person object using an array called range, and my range will have all of it. So that said, let's get back and run the run hello-world.go app. So, and if I go to, so 1 minute, I think I'm running it on a different port. So I'm running on port 4000. So let's go and hit it on 4000. So my hello world is a bit different here. So my hello world takes an argument called name, and if I pass slash name, so you will see my name gets displayed here. So on my next function is slash template, which is going to handle my CSS and design and everything, and then pass an object as well, object of person. So if I do template, you're going to see a nice shiny design page, and which is responsive as well. You can see it is fully responsive, and all the magic comes from these ones. So I have my base layout, and then I have my footer, header, and then I have a navigation element. You can see my navigation element here, which is basically this part of it. And then I have my footer as my footer. So I have my footer, which just says built using Golang, and then it displays the current year. So my footer goes here. You can see, okay, built using Go in, it doesn't show the year for some reason. Okay, okay. Why does it shouldn't show? Okay, current year, current year, current year. Then I go back to my footer. Okay, there is some continued field. Okay, I think my reference to the object is not global, so it's not going to work now. Okay, never mind. I have to fix that. Yeah, so the idea is just to pass the year element here, and once you pass that, it's going to display globally on all your templates and all the pages that you see. And then this is just an array of all your hard-coded data element that you passed here, which is basically your structs of persons. And if I had another one now, and then go here, and then say yes, yes, image here. Then if I recompile it, so if you see I'm running it directly, there's no need to build the server or do any build for your server. You just fire the server and Unlike Java, where you have to compile first and then you have to create a war file, and then you run the war file, deploy the war file into a web container, and then only you can test your application. With Go, there's nothing like that. There's no middleman or nothing like that. You can just directly fire it. And the language, as I said, has its own HTTP server out of the box. There's no extra dependency there. And if I refresh now, I should be seeing 3 of them now. So you can see there's another third one which has come now. Yeah, so that's said, that's my Hello application, Hello World application. Now let's go a little bit beyond the Hello World and make the application a little bit more complex and like a real world production application, So, so as I said, now you got an idea of how the templates work. Like you wrap all the files for your front end and then pass your object, which is a data layer. So now let's try to use a database and do some real application. So the structure for my application is a MVC pattern, which most of you will be aware, like model, view, container pattern. So your templates and static files are part of the front end element, which is your view. So my static elements like CSS and images and JavaScript all goes here. And my templates, as I discussed, all go in here. So I have a login page, a sign up page, and then a create page. And then I have a small customer data model where you go in and create some customer objects for your application. So my user model is like ID, name, email, and then hashed password, and then created time and active. And the customer model is simple. It's just ID, email, and ID is mostly auto-generated. And then you have an email, first name, and last name. And for this little demo, I've got a Docker container running on. So, okay, Docker is basically a container-based architecture which allows you to run applications as a not as a monolithic one, and it is lightweight. And the Docker application itself is developed using Google's Golang. So if I look at my Docker images, you can see I have my own MySQL server running as a container. So if I do Docker -a, I will show my MySQL container running. So Docker IT Docker MySQL bash. Now if I want to get into my container, I'm going to get into my container. Now you can see my command prompt changed into bash. So now I am into my container now. So and I can see if I do MySQL-root, and then it prompts show databases. So now you can see I use this snippet box as my database box. Show tables. You can see I have my customer table and users model. So I've already created the table for the demo. So I'm not going to get into the database level of it, but just want to show you where the database runs and what tech stack I use for my database. Yeah, that's said. Let's get to the model here. So I have my customer model, and then most of the then I need to have make some database calls, right? Like a normal crude application as a create, read, update, and delete services, right? Against database. So now I have my I have my customer model, which has some edit methods and a delete method and an insert method. And then I want to display the latest of the top 10 customers in my database. So the code, if you look, is self-explanatory. So I'm making a DB query. Okay, say get all of my customers, and then I create an array and I iterate through the result object and append it, and then return all my customers. So it's a clear only database level code. It's nothing else here. There's no template or anything here at this point of time. And then I have my user repo, which is all the user related, pretty much the same pattern. You have an insert, and on my user one, I have an authenticate request. So I will come to this in a bit. So my authenticate model gets the users on the login page, it gets the email and password, and then it makes a select query against the password and ID from the app user from my email. And then I scan the hashed. My passwords are hashed for security. It's not plain text. The reason is you should never store plain text passwords on a production server. It should be hashed and salted for security. And even the admin of my database, I won't be able to hack the password if I don't know the password myself. So that level of security will be there. So I compare the hashed passwords, and if they match, then I return the ID of the user. So and then I have a get user model. So basically gets the ID of results of the user. And then I have a change password method. So that's my controller models that I have. So I have a customer model. So the structure I use is you create a model file, which is called customer.repo, and then you put all your functions related to your database, like insert, read, update, delete. The same I did for the user model. So I have a user model and then all the database level calls, functions that I want to perform against this model. So we are good now on the model side, and now we get to the controller side. So if I want to handle all the customer related routes, so I have a create customer method. So if I go my structure, that's quite a lot of code. So I have a create customer, and I have a delete customer, edit customer, and different service level calls. So if you look at let's take a edit customer one. Edit customer model gets the request response object, and then on the request object, I have all the data coming from the form, like first name, last name, email, and then I say I make a call to my customer's edit method, which is now a database call, because I want to edit the customer's detail, right? Like first name or last name or email, and that will return an error. So we just now looked at the edit method here. So if you look at the customer model, the customer model has its edit method, which is basically an update query. And then once it's done, then I say customer is updated successfully, and then I flash a success message, and then add default data, and then redirect it back to the home page. Yep. So that's it. I'm not going to go deep into the code, but I will give you a structure by running the demo itself. So if I were to run the demo, so I do routers /run /routers. So let's wait for, okay, now it says server has started. Good. We are good to go. So if I try to access the application now on port 4000, I won't be able to access. The reason is it's all protected now. So I have to log in to be able to do anything. So if I hit, I won't be able to hit the customer model. So like say I want to add a customer. So if I try to add the customer, no, I won't be able to. But if you look at the source code, your header has customer one, add one. So if I click that, it's not going to work. So I have to now, let's say I'm a new user. I want to register as myself. So if I go Saravanan, and then I put see first test at test.com, then I put some password. Okay, now I'm going to log in. First test.com. So, okay, I'm now successfully logged in and I can see all my customer data. Okay, let's go ahead and add a customer. Let's see, and then go at gmail.com. So now you can see this new user, new customer called Babu at Gmail got added. Okay, now I want to edit the email address. So I have an edit method. So if I hover my edit icon, you can see on the bottom here, it shows something called customer/edit/19. Let's go to the routers now and track how it works. So if I go to my routes, so I've got a bunch of routes for my application. So I have something called edit/customer/edit. So you can see here it's customer/edit, and it gets the ID of the customer as one. And if it's a get method, then it goes to the customer form function. So the customer form function, all it does is just receives the ID of the user and then gets all the customer's data from the get method, which is related to the customer model, and then I pass it to the template now. So this is where the interesting bit happens. So I pass it to the template. So let's have a look at the template called edit.page.temple. So if I go to my edit.page.temple, so in my edit.page.temple, I have a breadcrumb, which basically this is what you see here. So when I click edit, so this is my breadcrumb, yeah. And then I have an header for my card, this is a card element, and header is update customer. And then I want to post my form action to customer edit/ID. And then if you look at the value part of the tag, I get all the elements from this template data, which I passed just now. So if I go back, and this is where customer data gets passed to the template. So on this template handles the data element for me. So that is in a nutshell. And let's have a look at how the delete works. The delete works the same way. So this delete customer function receives the response on writer object, and then I get the ID, and then I issue a request to delete the ID. Then once deleted, I redirect the request to the home page, which is what basically happens. So if I want to edit to, let's say, yahoo.com, and if I hit, now you can see it's edited to yahoo.com. Let's delete one of them. So when I hover the mouse to delete, you can see that my dynamic link is customer/delete/10. So if I delete that, it gets deleted. And if I go on my command prompt, I have a little message saying customer deleted successfully number 10. So item number 10 got deleted. So it's a good practice to log information on the database side. So I've done that logging here, and then I can log out. I can log in again. Test.com, test1. So yeah, so pretty good. And let's try to do a little bit of hacking here. So, okay, you can see I have something called this token is no more needed. Sorry about that. I need to get rid of that. So this is the cookie that is being used. So if you look at the cookie data, you will see it's all in encrypted format, and it has an expiry of 1 hour from now. So let's try to do a little bit of hacking. So I open another command prompt and try to do a little bit of social hacking here. So let's say I want to get my customer data. Yeah, customer. I want to get the customer data. So it's not letting me do now. So you can see it's redirecting me back to the login page. The reason it's doing is I'm not authenticated. Basically, I don't have the token. Let's try doing it with the token now. Yeah, -cookie, and I know the cookie name is login -cookie, and I put some a bunch of text just to see what my application does. Basically, as a hacker is trying to just send some fake cookie now, so it doesn't lets me go in. So it say it's not found. Basically, it doesn't allow me. And what if I try to pass a genuine cookie? I just now copied from here. Yeah, and I put it here. Okay, now it's a genuine login cookie, and then I'm passing it now. It doesn't let me do that. The reason it's not allowing me to do is because I've made it HTTP only, and when you make a HTTP only cookie, it's really hard to hack now. Even though someone gets hold of the cookie, it's really hard because the way I've done the encryption, it makes it really hard for social hacking to happen. So yeah, so that said, we got a running application with a bit of authentication and a production like kind of an app now. With you can see I can add a customers, and I can do some edit profiles also. I can edit my profile also and change the password if I want to. Like say if I want to change my password to test one test, and then I change password. So the application got changed and successfully. And then if I try to test.com and I'm trying to log in with my old password, it won't allow me now. Test.com, and then if I try with my new password, it allows me. So that's a little demo of how a crude application works. So now you can see here also gets modified. That's a simple demo of a live application. So now, what if I want to actually make this application accessible globally to everyone? You know, this is fine. Yeah, I've done login, log out, blah, 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 all this. What if I want to do something really interesting, you know, like not running it on my local? I want to make this application available to everyone on the world. So how do I do that? So in order to do that, you need a server, obviously, on the cloud. And then you run and you deploy your application. So let's do that straight away. So in order to do that, I need a bit of a tool. I use something called Fabric, which is a Python. If you Google Python Fabric, Python Fabric is a build deployment tool, which is very famous, lightweight. It's like writing a text file basically. So what it does is basically deploys your app to a remote server. So if I'll show you what I've got. So I have a cloud server, and now I want to deploy this app. So all I'm saying is, okay, this is my home. I have a public key and private key. So no one can log into the server without the public key and private key. And then I build my Go application to that of a Linux version, because I'm running this on a Mac, but I want to, my target server is actually Linux. So I say my environment is this, and please build it for a Go Linux version and not Mac version. Yeah. And then this is my exe file, or you can say binary file. And then I deploy all my templates and all these ones. And then I run a small bash script, which I will show as well. So this is my bash script. This is saying, okay, this is my root directory, and just run the application. That's it. So let's go ahead and deploy the application. Yeah. If you want to deploy the application, all you do is fab deploy, because that's my method name on my fab file. So that's the name I've given for my Python function. So my Python function, all it does is, okay, these are my files in the local. Now push it to the remote server and run this bash script, which is basically starting my application, which is my login demo binary file. Yeah, ready? Let's do a fab deploy now. Okay, cool. So now you can see it's building the router, and now it's pushing things to my remote server, which is my server is IP is surround.uk. And let's give it a few minutes because it's a 12 meg file. Okay, good. So let's try and now go and access this file, go.surround.uk. Okay, cool. If you have your smartphones, now if you go and hit go.surround.uk, you will be able to access this application live on your phones. So let's say I've already registered, so I'm not going to register again. So if I do a test, so you can see I'm logged in now, and whatever you saw on your local, you're seeing it live now. Can you see? This is my local host 4000. So whatever I demoed here, it now is made live and available for everyone to access. So if you fire up your smartphone and hit go.surround.uk, you'll be able to fire the application directly. And that's how simple and easy it is to build an application using Go and deploy it on the live server. And if I go on the live server, so let's do SSH UK. Then this is my demo. So you can see if I do a ls-lah, you will see the timestamp is May 31st, and all these files got deployed just now. So yeah, so that's it. I want to say. So basically, this is just a tech demo. So I will make the source code available as well. So my source code is on bitbucket.org, and I used you need a source code control, right? So is everything on the Git project. So I have so you can see model, router, static, and templates, and then I have my fab file, and then helloworld.go, which I demoed just now. So yep, so that's it for the demo. So if you have any questions or anything, I hand it over back to you. You have any questions?
Yeah, audience, if you have any question, please ask.
I was trying to do it right, like the Go is pretty new. So you should basically go download and try, and so the file extension for the Go files is .go. So all the files is .go, whereas the binary files don't have extension direct code. I do a look at it. Have extension. Whereas if I have for Windows, you will see it will show .exe, but where from Linux world there is no for binary files. So I think you can ask questions You don't have to type on the chat. Just unmute yourself and ask if you have any questions. Just yeah, if you don't have any questions, you can just pass on to the next presenter. Yeah.
Hello, Saravanan.
Yeah. Hello.
Yeah. One question posted in chat section. Can you
Okay.
see? Navin, sir, which platform this Go language is being used? Name the terminal where you are working. So this question is posted in chat section.
Yeah. So basically, this the concept of terminal doesn't exist in Windows. Windows, you call it as command prompt. Whereas on a Mac or a Windows or a Linux, you call it as terminal. There's just a naming difference, basically. And then you have to use something called curl. So if you're coming from Windows platform, I'm sorry to say you don't have those tools for Windows. Windows world is pretty small. You have to start using Linux. At least if you have laptops, go and format your laptop and install a decent Linux flavor like Ubuntu or Mint. There's quite a lot of flavors of Linux versions are there, like Ubuntu. Ubuntu is it's a bit heavyweight, but you can use Mint OS. There's a wide variety of lightweight Linux tools here. So if you want to do some real program, you have to not use Windows app. And there's no virus. The same state from day one to day out. In this 11 days, it won't trouble for the restart. So, yeah. Yeah, so how is the Go language user-friendly when compared with other languages? So as you can see, the source code itself is pretty clean and readable, and no big third-party libraries are needed to build a robust, highly scaled application. So in my demo, I just used Gorilla Toolkit. It's not a framework. Remember, there is a difference between a framework and a toolkit. A framework is a heavy. The success of Java is not its language itself. It's because of billions of money the third parties have built. Like Spring. Spring is a $500 million company. Yeah, they've invested slashed quite a lot of money to make Java a big library and a framework and make the life of developers much easier. So, but that doesn't have to be the case with Go. Go has what those 500 millions have been invested. They have been already hooked up into the language at the core of the language itself. That is the strength of it. So Go is a server-side language. It's not a front-end language. You have to make a clear. Someone has asked the question, can you make front-end GUIs using Go? That's a wrong requirement. Go is a back-end server-side programming language. You can bring your whatever front-end you want. So in my demo, I used normal HTML and I didn't even use even a single line of JavaScript. Only front-end. is HTML, and then Bootstrap is what I use for the design element of the front end. Yep, that's. So you can do pretty much a lot of, it doesn't have to be front end or a web application only. Go can be used for building a lot of other different types of applications, like applications, I'm not sure how familiar people are with Docker. Docker container. Docker is, so you can see Docker is a multi-million-dollar company now. It's a container-based architecture design, and it's very popular for writing microservices using Go. And this entire Docker container architecture is written in Go. That is one of them. And then something called Kubernetes. The Kubernetes is another production scale container orchestration architecture. And Kubernetes is completely written in Go as well. There's a tons of modern, highly scaled production grade products coming in, all written in Go. So these are not web applications. Remember, these are infrastructure, network level applications, and helping you to build modern cloud, highly scalable computing architecture. So these are all done in Go. So these are not web applications. So my demo is a web application, but you don't have to necessarily use Go only to build web applications. You can build quite a lot of command line applications like Docker and Kubernetes and other. There's another CMS getting built as well, which is called Yugo. This is completely built in Go. And there is a modern web server called Caddy. This Caddy web server is completely written in Go. So these are the modern use cases. A web server can be written using Go. This is trying to replace Apache. Apache has been in the market, Apache HTTP server, not the Apache Tomcat server. So Apache HTTP server has been in the market for around 20 years now. And this is competing with that, actually. So you can use this server for, Nginx is another popular. If you're coming from Windows world, I'm sorry, this all are going to sound French for you. Nginx is another reverse proxy server, which is very, very popular on the modern application stack. So this Caddy web server, which is written completely in Go, is trying to compete far ahead with Nginx and Apache, which are pretty mature players in the market. Yep. So that answers the question. So can you suggest any study link to understand more about Go? You don't need a study link. You have it on your smartphone these days. You just type Google Go go to youtube.com, and if you type Go, it has a ton of Golang. There's a ton of tutorials for free. Instead of watching some movie on the YouTube, just go and type Golang on YouTube, and you will be able to there's tons of tutorials. There's so many tutorials available. There's unlimited resources there at the moment. It's one of the popular languages now on GitHub. So you can see so many resources available. There's no shortage of resources. It's shortage of interest to learn. That's what I would say. Yep. Okay, I didn't share the screen, I think. Sorry about that. Yes, so if you go there, so you can see Caddy is another. So Docker is written completely in Kubernetes, and then Kubernetes is something OpenShift's server orchestration framework. So that is also written in Go. Then there is a web server called Caddy. Caddy is a web server which is pretty much used for reverse proxy and stuff like that. And Nginx is also a popular one. So if you go and hit go.surround.uk and just inspect the elements here, and if you open the network tab and just do a request, and then if you look at the request, my actual server is served by using Caddy actually. So my Go application is actually served by Caddy. My caddy server is what is actually serving your front end web app. So I'm actually actively using caddy as my front end server. So my application cannot be directly hit without going through this caddy web server. Yep, that's it. Yep. So any more questions? Yeah. So where it is applied, it's applied. Docker is a famous. You need to Google a little bit about what is Docker and where it is used. Docker is used is a lightweight microservice based architecture, and rather than building a monolithic application, microservice architecture is getting quite popular, where you separate your architecture and avoid single point of failure in your design layer. Yep, that's it. So any more questions? Yeah, so there are limitations in Go. It's not that this is not one of the super language or something like that. So I've already showed the limitation. The language supports quite a lot of things which are hard to build, and the missing ones are session management, security, and routing. But as said, this is handled by your Gorilla Web Toolkit. If you are using this Gorilla Web Toolkit, you will be able to get them out of the box. So you are not missing anything. If you look at Java, it doesn't have anything out of the box. Actually, you don't have. You might have session management, but as I said, you don't need sessions. Actually, this is an old way of writing applications. If you are going to use sessions, so session is an old way of building applications. So you don't need that actually. And then security. Security is you have transport level security built into the language. It's not that Go is insecure language or something like that. But application level security, they don't provide. They are letting you bring it the way you want it. Because in my application, login, logout, I built completely using just one toolkit. There's no massive code in the toolkit. It's just 10 lines of Go file the toolkit uses. It's not like if you open Spring Boot or Spring Java frameworks, there are thousands and hundreds and thousands of Java files hooked up, and 500 million and billions of money being dumped to build this layer, which you don't need. You get free now out of the box. Yep. So you have any more questions? So Go language, as I said, is developed from coming from Google. So I don't have to say how big Google is. It's developed by Go. What is the scope of Go in industry? Docker is the example. So Docker is lightweight. You don't have to pay tons and tons of money for your production application server. If you're going to build an application in .NET, good luck, because your operating system needs a license. You can't run a production .NET application without paying license for your Microsoft, right? Microsoft runs on Windows Server. Windows Server is not free. You have to pay several hundred thousands of money for your license. It doesn't come free. Whereas with the Linux, I can go to any cloud computing platform and spin up a Linux VM for just $5. And there is no licensing cost. It's all open source. If I have to deploy this demo application using a .NET stack, I have to spend like at least $200. But whereas for this demo, I just spend like $2 to run this demo. So that is what I'm prepared to do. You have to build something so on, something in Java or .NET. And my server has got only less than 250 MB RAM. That means you don't need a massive. So Java application, you can't run an application in 512 MB RAM. You just need at least 1 gig for your Tomcat to run the application, right? So but the world still believes in Java and .NET, particularly in India. The students, they don't know anything outside of Java and .NET, sadly. But the real world is completely different. .NET, there are lots of alternate ones, like I said, Ruby, Ruby is another famous scripting language, and then you have Django Python. So this is a very popular framework, Django Python. I would strongly recommend using this Django Python, and then you have what you call Node.js, which is a completely JavaScript-based front-end framework and a server-side scripting language. And then there is something called Express.js. Express.js is a comes with an ORM, object relational mapping tool as well. So you could do you have lots of alternate web stack for building applications. Java and .NET are not the only ones in the market. Yep. Yeah. Any other questions? Yeah, Go can handle. You can see Kubernetes is designed for handling thousands of servers. Kubernetes can handle 100,000. You can spin up 100,000 VMs at production scale in just one single click. That's how much scalable Go is. This entire Kubernetes is written in Go. So if Go is not able to scale, then why would a production grade container orchestration would be written in Go? It doesn't make any sense, right? They should have gone for Java stack or .NET stack to do this for spinning up 100,000 servers. If I have to spin 100,000 servers automatically, it's not possible in the traditional cloud space at the moment. You need Kubernetes, and this Kubernetes is completely written in Go. That is a proof that Go is that much scalable on the server side. Yeah, it can handle big data. So server orchestration is handling quite a lot of data. And so C is quite popular. The reason C is popular is because it can work at OS level. So if I build a C application, what you get as a binary is doesn't need a JVM or anything. It gives a binary file which makes a OS level communication, and the same pattern the developers of Go used it. So the developer behind Go, Rob Pike and other three guys, they are the writers of C. So they designed C at AT&T Bell Laboratories, and they designed Go now. And with that in mind, now the only language that is equally in speed and handling low latency is Go at the moment. C++ is not designed for modern architecture. It doesn't have any web server. It doesn't have any. It's pretty old, right? So C is quite modern. It has it brings both the world. You can build system programming completely in Go now. You don't have to use C anymore. So it's a good competitor for C. Yep. Yes, so that's it. I think I've taken quite a lot of time, and I let you take over.
Yeah. Let me conclude this session, sir. I very much thankful to Saravanan who delivered wonderful session. Your session is informative and easy to follow, sir. Also, your QA session is also informative. I hope it is very much useful for our students. I hope our students will learn Go language in the future. I thank all the participants for patient listening. Once again, I thank you all.
Participants, we shared the feedback link that will be active for another 15 minutes. Please kindly use it. Hello? Hello? Dear participants, I shared the feedback link. Please kindly fill the feedback link. It will be active for another 15 minutes. So tomorrow's session will be start by 11:30. Thank you. Thank you once again.
Thank you, Saravanan. Bye.
Thank you, Saravanan sir.
Thank you.